Yeah. A warm good evening to one and all after the lunch break. We have our next speaker for this program, Dr. Ayyanna Habal. A brief introduction about Sir. He is currently working as an assistant professor at Pandit Deendayal Energy University, PDEU, Gandhinagar. He has earned his PhD from IIT Bombay and completed his master's degree in highway engineering from Bangalore University, Karnataka. He is a graduate of civil engineering from PDA College of Engineering, Karnataka. After his master's degree, he started his career in research as a senior research fellow at one of India's premier institute, Indian Institute of Science, Bangalore. After working at IISc Bangalore, he joined for PhD at IIT Bombay under the MHRD fellowship. After the PhD degree, Dr. Habal worked as research associate at IIT Bombay. He is a recipient of Professor Justo Gold Medal for outstanding performance in the Master of Highway Engineering and has excellent research and consultancy experiences. He was associated with more than 50 research and consultancy projects in pavement and geotechnical engineering for various government and private consultancy projects during his master's and PhD programs. He has delivered many invited talks and webinars for FDPs and SCTPs for various institutes in Karnataka, Andhra, Tamil Nadu, Maharashtra, Gujarat, etc. Apart from having exposure to field and consultancy projects, he has participated and presented research papers at national and international conferences. He has published more than 17 research articles in reputed journals. Currently, he is an associate member of Pavements and Materials Technical Committee of Transportation Research Group, TRG, India, and the American Society of Civil Engineers, ASC. So welcome, Dr. Ayyanna Habal, for this program. And I would request him to take over the.
Thank you so much, Professor Niranjan, for a very nice introduction. I think we can start, right? I can see around 25 participants are there.
Yes, yes.
Okay. Good afternoon, all. I know it is quite difficult to attend lectures after lunch break, right? I know it is same way for me also. It is difficult to convince or keep you all of you interesting. So I will try my best. I hope this is because the topic is very interesting. You know, structural evaluation and strengthening of flexible pavements using FWD technique. This is one of the newest technique which is already suggested by NHI. If any of you are aware, earlier we used to adopt BBD, Benkelman beam deflection, for this purpose, structural evaluation. But now already NHI has mandated we have to go for FWD only. So, you know, the problem is there are many drawbacks with the existing method. That is the reason NHA has mandated for FWD. That I will be covering what are those aspects. Though earlier speakers have discussed related to evaluation, pavement evaluation in general, both functional evaluation, structural evaluation. I hope Dr. Ankit Gupta has already covered it. But I will be covering more in depth regarding structural evaluation, specifically using FWD technique. And one thing is structural evaluation. Next aspect is strengthening of the flexible pavement. That is in terms of overlay design. Okay. And contents of the today's presentation is introduction, followed by functional and structural evaluation. Both briefly, I will touch upon functional evaluation and various methods adopted for structural evaluation. And then I will be concentrating more, little bit on the BBD and then more on FWD. Okay. Then overlay methods, then FWD technique. In detail, what are the various parameters or equipment specification, then how to conduct this survey. After conducting, how to analyze this data. That is very, very important. Then back calculation of model I. You know, one of the important aspect in FWD technique is we have to back calculate the modulus of existing pavement layers using FWD data. For that, there is a small software available, KGP back. That also I will show screenshots. If time permits, I will demonstrate that as well. And at the end, I will summarize quickly what are the steps involved in overlay design using this FWD data. Then summary and takeaway from the today's presentation. Let's start. Before that, I would like to give some statistics related to roads because it is more relevant to this presentation, that is a pavement evaluation. How many of you are aware how safe our roads are? You know, there are so many accidents happen every day. We may not be aware. During COVID, we might have kept a tab on checking the number of cases, active cases, recoveries, also deaths, right? But no one have checked these road accidents. If you see, these numbers are not less, very high. For example, for 2019, as per MORTH report, road accidents were 1,51,000 plus deaths were occurred only due to road accidents in the year 2019 alone. You can imagine how many deaths are happening in roads. It is all over India. And if you take it average, there are 415 deaths per day. Every day, 415 people are dying because of road accidents. See, these numbers are only due to death. I'm saying these are fatal accidents. If you see injuries and all, it is thrice, almost triple the number. And remember, these all are based on reported number. We all very well aware that all the accidents will not be reported. If small accidents are there, usually they will be sorted in field itself without reporting. Now you can see so many accidents are happening. If you compare with the world, you know, where do we stand? At first rank. We are leading in road accidents and deaths due to road accident in comparison with 199 countries. It is not something we have to be proud. We should not lead in this aspect. We should lead in with respect to the safer roads. If you see, as per 2018 data, statistics says India is leading in road accident and deaths, followed by China and US. This is definitely threatening. And you know, out of these number, lion's share is because of bad roads. I'm sure everyone might have heard of news regarding potholes, accident due to potholes immediately after monsoon. It is very common. It is not limited to potholes. There are many failures occurs because of heavy loading, rutting, cracking, poor maintenance of the roads. There are so many distresses in the roads. Okay, so lion's share of number is because of bad roads. So we should really look into this aspect so that we can reduce these numbers. Okay. Now, before going into presentation, I would like to show briefly how a typical flexible pavement looks like. If you see, when we are driving on a road, it looks very nice, right? Black top with a very nice marking, central lane marking, side marking and all. But many of us are not aware what is underneath. There are many layers. Each and individual layer have their own function. Each and every layer is designed and constructed scientifically. Okay, all these layers, they bear loads and they will transfer loads to underneath layer and finally safely transferring the load within. It will create damage into the pavement, or it will start showing in terms of rutting or fatigue cracking or so many cracking. Okay. Organizers, just let me know if I drop out from my connection. It is showing poor internet connection. Just I will close my video so that bandwidth will be more.
Okay, fine.
See, the thing is here we have to understand there are various layers and pavement can fail due to enormous reasons. Either it can be any problem in subgrade or embankment or base course, sub-base course or even surface layer. Or it can be even due to poor construction or poor QC. Okay. Finally, it will reflect it on the surface, either through settlements, failures, in terms of distresses or differential settlements, etc. Okay. So these kind of pavements in service has to be evaluated periodically to see their functioning. Okay. Either it can be functional point of view or from the structural point of view. During service life, what happens? Due to the repeated application of the vehicular loads, because dynamic loads are plying on the roads, right? They will create or they will damage the road. Okay. So we have to reduce that, or we cannot control everything, but this deterioration should be in such a manner that it should not fail until its terminal life is reached or design life is reached. So periodically it has to be assessed. It's both functional as well as structural conditions. Okay. And functional aspect can be assessed through roughness, that is the unevenness of the road, and skid resistance can be assessed through its surface by checking whether pavement has become smooth or not. And also drainage properties. Water should not be stagnant on the road. Remember, all these aspects affect the functional performance. Either it will lead to the skidding of the vehicles and leading to accidents, or even if water is stagnant on the road, it will disturb the visibility and it will lead to the accidents. Because of hydroplaning also, skid resistance will drop. Okay. And because of uneven road, comfortable riding quality will be poor and passengers will uncomfortable, and also it will increase the road user cost. Okay. Anyways, I'm not going in depth for functional evaluation. Today's presentation, I'm restricted to structural evaluation. Structurally sound pavement should be able to withstand repeated application of wheel loads. Roads are meant for repeated application of wheel loads, right? So even after applying many vehicular repetitions, roads should withstand that road or wheel loads coming over it. Okay, it should withstand until its terminal life, that is till the design life. Okay, but there are many ways it may not function properly. Means it may not withstand the loads, either due to the lack of support from the subgrade, or maybe individual material property problem at individual layers, like it can be asphalt layer or granular layer or subgrade layer. And there can be any variation in the traffic loading. During construction, there might be different loading, and in service life, there might be increase in the traffic loading, or also adverse environmental conditions also lead to the structural inadequacy of the pavement. Okay, but the thing is, one has to evaluate whether really the structurally pavement is sound or not. That can be assessed in various ways. One such method is BPD, Benkelman beam deflection studies. I hope many of you are heard of this, because last 2 to 3 decades it's been used extensively. Now slowly we have shifted to FWD, falling weight deflectometer, that I will be covering in detail. This is the BBD and this one is FWD, and DCPT, dynamic cone penetrometer, this particular test setup. This can also be used to assess the individual layer strength in terms of CBR and also approximate thickness of each layers. And GPR can also be used as one of the NDT testing method to check or verify the layer properties, individual layer properties. Okay, then destructive methods, where we can cut upon the pavements, either make a trench and take the material and test it at lab, or we can drill a core into the pavements and assess the material properties in the individual layers. Okay, this can be another method. Today's presentation, I will be concentrating more on this PBD and FWD. Okay, the thing is, if after assessing through any of these methods, if we found that pavement is structurally not sound, then what to do? Here comes, we have to strengthen, right? Basically, if it is not a sound, we have to either increase its strength through some means, or we have to leave it until it fails completely. It may drop, we have to see the remaining life. It may not reach the design life. Okay, let's see how to do strengthening. Most common practice is by providing an overlay. Means add extra layer over the existing pavement. That is called overlay. Basically, this will add to extra life if it is a structural overlay. Otherwise, there are various ways why we provide overlay. Okay, see, for example, to increase the load carrying capacity of existing pavement. For example, during design, the load carrying capacity was different. Based on the traffic survey, you might have designed something. Later on, during service life, if the due to diverted traffic or due to any other establishment, if the load plying on the road is increased, then to cater that loads, we may have to add one more overlay, okay, to serve the purpose of increased loading. And then to correct the defective surface condition, to rectify the surface defects, distresses, one may give extra overlay. And also for the pavement maintenance, periodically there will be a resurfacing we call, or overlay will be given so that it can successfully reach its design life. Okay. And also from the functional point of view and sometimes aesthetic point of view also, overlay can be provided. For example, if the pavement might be structurally adequate, but it has become smooth because of traffic and all, in such cases, one may have to provide another overlay or another layer just to increase the skid resistance. Okay. And finally, to strengthening of the pavement. If it is not structurally sound, if the pavement has dropped its structural adequacy, then one may have to provide an extra structural layer over the surface of existing pavement. Okay. That way, one can strengthen the existing pavement condition. Let's discuss various methods are there, like we can provide a bituminous overlay over the bituminous pavements, or even we can provide bituminous overlay on the concrete pavements also possible, and concrete overlays over the bituminous pavements. Nowadays, if you have heard thin and ultra thin white topping, those are the concrete overlays over bituminous pavements and concrete pavements. That is also possible. Okay. Then comes, but I'm not going to discuss all these. It takes a really good amount of time. I'll be discussing bituminous overlay over the bituminous pavements. Okay. Now the question is how to design this overlay. As I said, subjectively I mentioned, if our pavement is structurally inadequate, then we can go for an overlay. But we cannot simply say it is structurally adequate, or we have to quantify it. We need some parameters so that accordingly we can provide a suitable thickness of overlay. Okay. There are different methods, like one is deflection approach, which was old method. Back then we used to use a Bankelman beam deflection method. Okay. Now new method is a mechanistic empirical approach. Mechanistic empirical approach, in this we will adopt FWD technique. Okay, that I will be covering in this presentation. In deflection approach, basically, based on the deflection of a pavement under a standard load. For example, if we compare these two cross sections, for a same load, if we apply here, in this case, this deflection is not much, but in this pavement, this deflection is more. So this indicates this particular pavement is weaker compared to this pavement. So that way we will get to know the structural adequacy of the pavement. If the deflection is more, that indicates that pavement is weaker, and we need to provide an overlay to bring down these deflections under the limits. This is how one can provide the overlay in this method. And in mechanistic empirical approach, we have to calculate the remaining life of the existing pavement. Remember, initially we have designed the pavement and constructed pavement considering some years of the life, maybe 15 years or 20 years for a flexible pavement. Maybe after passing 5 years, we have to check the structural adequacy, whether the same pavement will continue to cater for another 15 years, which is remaining life, whether it will serve or not, that has to be checked. Okay. That can be done by checking the fatigue cracking criteria and rutting criteria, which has been given in IRC 37. Okay. And based on the remaining life, we can assess whether thickness of overlay is needed or not. If needed, how much it is needed, that can be assessed. Okay. Falling weight deflectometry can be used for estimating the remaining life. That I will show you how it can be done. Okay. And already well-established IRC guidelines are available for both the methods, for BBD method as well as FWD. This is the new method, that is IRC 115 is applicable for this. Okay. And let's see why NHI and why we are shifting to FWD. Okay, what is the problem with the BBD? BBD was developed under R6 research project of MORTH, which was 2 to 3 decades back. It was developed. It is used in India extensively. Even many developed countries till now they are using. In fact, even in India, we use for less importance loads. Okay. The first code, IRC code related to BBD was released in 1981. Okay. And BBD is used for measuring the surface deflection of the pavements under static or creep load. Means you can see this is a typical photograph of a BBD survey where a standard axle loading will be there. Means this truck is loaded to a standard axle loading, and under this load we have to measure the deflection. Okay. And after at this condition, pavement will be under deflected condition, will be measuring, and slowly it will move further, and whatever recovered or rebound deflection we call, then we will take that one. Okay. This is either it is static or slightly it is moving at a walking speed. That is the reason it is called measurement of deflection under static or creep load. Remember, this is not the case in field. Vehicles will be moving at higher speed. They create more damage, right? Dynamic loadings. That is one of the drawback I can say that I will cover in the next slide. But this is quite popular, 2 to 3 decades we have used. Even now also many countries, many developing countries, they are using, majorly because it is easy to conduct and analyze the data. Very relatively easier for conducting the survey and also analysis of the data from BBD, and lesser cost of the equipment. You can see this equipment is very simple, and cost of this equipment is also less, very less compared to FWD. Okay, and skill set required is also less. With the laboratory assistant or with a little bit of training, we can use any manpower for conducting this BBD survey. Okay, these are the advantages. Because of that, it is extensively used. But let's see, there are downfall of this is the drawbacks of this BBD method is static load is used. That is the purpose. It has to be because of static load, we are measuring the deflection, and it's more labor intensive. One thing is it is measured under static load and more labor intensive. One of the drawback. And next is this method was developed considering the thin pavement layers. Remember, I'm saying this was developed 3 decades back, 2 to 3 decades back. That time we had different mixes, bituminous layer, bituminous macadam, premix carpet, which are rarely used nowadays. Okay, and the current pavement thicknesses are very thicker bituminous pavements. So it's a dense bituminous macadam and bituminous concrete we use. Okay, and most importantly, pavement in field encounters dynamic and repetitive loading. Moving loads will be there, but whereas we are measuring under static condition, so the field simulation is not proper. It is not representing the actual loading condition. Okay, and another concern is repeatability of results. Okay, because of involvement, manual involvement, there are high chances of error involved in this. Okay, and properties of constituent layers cannot be predicted. Remember, this is the biggest drawback. Because of that, we cannot predict the remaining life. Whatever we are getting is deflection because of all the layers. It is a combined effect. We are getting at surface deflection at one point. Okay, from that it becomes very difficult, or we cannot calculate the constituent layers properties like modulus of each layer. It is not possible. Okay, and how to overcome? There are so many drawbacks or challenges with BBD. How to overcome these drawbacks? That is where FWD come into picture. Okay, if you see, the FWD works on the principle of applying impulse load. One of the drawback in the BBD was creep loading or static loading, and static loading we were measuring. But in FWD, it applies the impulse loading on the pavement, and it measures the deflection bowl under impulse load. Deflection bowls means it is not a single measurement. At a series of measurements will be taken to form a deflection bowl. If you see, this is a deflection bowl under the loading. Okay, and therefore, because of this impulse load, it closely simulates the duration and amplitude of the load pulses which are produced by moving vehicular loads. Okay, and since more than one surface deflections are measured, more information is available about the pavement. Here we are not taking only one deflection, we are taking series of deflection at different locations near the loading area. So to get this complete deflection bowl. Okay, and that has influence. From this easily one can calculate the constituents. It's not that easy, but I will cover how it can be calculated. Okay, And there was a circular released by Ministry of Road Transport and Highways. They said all the roads has to be evaluated using NSV and falling weight deflectometer for road asset management system. This is for all PWDs, NHA, NHIDCL, BRO, etc. Okay. This is a recent last year notification or circular. Okay. Now you can see no longer we are into BPD. So it's good to understand, learn about FWD, so that in future we are going to use this one only for the evaluation. Okay. Now I would like to cover more aspects of the FWD. This is a schematic presentation of FWD. If you see, this is the trailer type FWD. This is the point of interest where we would like to measure the pavement condition. Here input force will be, the load will be lifted and dropped to produce an impulse load. Okay. And at series, there will be geophones will be connected to measure the deflection when the load is applied on the pavement surface. And if you see, even under the plate itself, measurement can be done. That is a maximum deflection. And at different spacing, these geophones are set to measure the deflection, which correspond to different layers. That way it will help to measure modulus of different layers. Okay. And different parameters in deflectometer FWD is impulse load of 40 kilonewton, standard load 40 kilonewton it has to produce when it hits the road. Okay. And loading period is 25 to 30 milliseconds. And measure surface deflection profile, means deflection bowl has to be captured. And back calculate the material modulus. This can be done by comparing measured deflection bowl and estimated deflection bowl. Means we have to estimate a deflection bowl in such a manner that modulus of each layer has to be adjusted. Okay, that is a kind of trial and error process. It is not simple process. It is a tedious process if somebody would like to do it manually. And almost it is closer to impossible. Okay, that is the reason there are so many algorithms, softwares are available. One such software is given by IRC also, along with the guidelines. We will get a software to back calculate the modeling. Okay, that I will cover in subsequent slides. I would like to show a short video of less than 2 minutes to see how this equipment looks like. Okay, this is a trailer type FWD. It is an animated video. Later on, I will show actual photos of FWD. Okay, this yellow color you can see, these are the geophones which will acquire the deflection data when load is dropped on the pavement surface. See, because of this trailer type or vehicle mounted deflection FWD, labors can be reduced. You can see here loading arrangement. This load can be lifted and dropped to produce an impulse load. You can see while measuring, this plate has to be in contact with the pavement surface. When load is dropped, at that instant of the time, all the geophone records the deflection data. And also peak load will be recorded. Okay. And these geophones are set at a series at different intervals. Around 4 to 9 geophones can be used depending upon our requirements based on the pavement thickness. Okay. And it is a quick method. Just at each location 4 times it has to drop and all the data has to be acquired, and it can be further moved to next location. It is a vehicle towed or vehicle mounted, so easily the majority of the work can be covered within less time. Okay. Then next comes the parameters. As I said, 4 to 9 sensors can be used, or even 6 to 9 depending upon the requirements and type of the FWD. Sensors are placed or geophones are placed at exactly under the load drop weight, that is 0 distance, then 200 millimeter distance from the loading point, 300, 600, likewise up to 1500 or sometime even 1800 millimeters can also be used. Okay. If you see this drop height, there are various type of drop height, 100 to 650 to 350 kg combination is there. Remember, one can adjust weight and height to produce a target peak load of 40 kilonewton. This is important. Our interest load is 40 kilonewton when it drops on the pavement surface. Okay. And these variations will be given because same FWD can be used on runways as well. Okay. And circular plate of 300 millimeter diameter is used with the rubber padding so that firm contact will be there with the road surface in the loading plate. And there has to be arrangement which can record the peak load and deflection bowl at the same time. Okay, this is very useful. With this data only, further one can calculate the modulus of the each layers. Now we know about the instrument. Let's understand, before going into FWD survey, there has to be a set of exercise one has to do. Okay, like all the relevant data of that particular interested stretch has to be collected. It can be initial design data, later on whatever the changes in the construction or any maintenance or earlier overlay history, everything has to be collected. Okay, then pavement condition survey has to be conducted from the rutting and cracking point of view. Basically, to identify the uniform sections. You know what we do for each lane for 50-meter length, means 3.5 meter by 50-meter blocks has to be considered, and each block we have to check for rutting and fatigue crackings. Okay, and we have to identify the uniform section in terms of good, fair, and poor as per IRC guidelines. For example, we can say good block if it is having isolated cracks less than 3 millimeter and which is less than 5% of the area, and also rutting is less than 10 millimeter. Like in that case, we call it as a good section. Likewise, if the wide internally connected cracks of width 3.3 millimeter having more than 5% up to 20% cracking is considered as a poor. Also, or either or if the rutting is more than 20 millimeter, then that particular section is considered as poor. Remember, this is important. This has linked with the further survey. So that is the reason everyone has to do this before going to field with the FWD equipment. Okay. Once we have this information, we should know how many data points has to be collected. Okay. Because based on this pavement condition, we have to take the data points. For example, if we consider single lane two-way, we have to conduct it every 60 meters. If the pavement condition is poor. If pavement is good, only 1 point at 500 meters is enough. You can see it is almost 8 to 10 times. See the difference. So basically, if our pavement section is poor, we need more data points to represent that particular pavement section. Okay. After knowing this, we have to go to the field with the FWD setup, and at each location, a seating load is dropped at first. Remember that seating load is just to make the firm contact of the plate with the road surface. That data will not be used for analysis. Next 3 drops has to be dropped, and that data has to be taken for the further analysis. Okay. And average peak load and peak deflection for 3 drops has to be collected, and also record the pavement temperature at 40 millimeter depth for every 30 minutes. This is also needed for the correction. Remember, that is the reason every half an hour we have to take the pavement temperature. And also there is a criteria, if the pavement temperature is exceeding 45 degrees, then FWD test should not be conducted. Why it is so, I will cover while conveying the corrections. Okay. And in addition to this, we have to collect the existing pavement thickness, which is very important. For further analysis, we are going to use existing layer thickness. For that, either one can take a test pitch section at every half kilometer, or we can use a GPR or any alternate method where we can get the actual thickness of each layers. Okay. Then comes analysis of FWD data. See, after collecting all the data from the field, we have to perform these steps as a data analysis process. First, we have to process the load and deflection raw data. Remember, when we get data, we cannot simply use all the data for analysis. Okay, that I will cover in further what has to be done. Okay, and identification of homogeneous sections. Then comes back calculation of layer moduli using a KGP back software, and then applying the correction for the temperature. This is for bituminous layer, and then applying the seasonal correction for granular layer and subgrade layers. And based on these moduli and existing layer thickness, one can determine the remaining life of the pavement. Okay. Now let's see these steps in detail. Okay. First, after measuring the deflections, we have to see whether it is making sense or not. Result should decrease with the distance. Means definitely deflection should be more under the load, wherever load is dropping. And accordingly, the deflection should decrease with the increase in the spacing of these geophones. Okay. And deflection should not be more than capacity of the sensor. It makes sense, right? If capacity of the sensor is more, that indicates what it is a crossing its limits, means possibly deflection is more, actual deflection is more. So we may have to go for a higher capacity sensors. Okay. And then normalize the deflections for 40 kilonewton. See, we need a standard 40 kilonewton loading. But in reality, when we conduct, we will adjust height and weight, but target peak load will be, it will be slightly higher or lower. Okay. So we have to correct it for that. For example, we can use linearly, like if the measured deflection is 0.8 millimeter at a target peak load of 45 kilonewton, recorded peak load, then 40 by 45 into 0.8. This way we can correct the deflection data or normalize the deflection data. Okay. Remember, after normalizing only, we have to use data for further analysis. And then we have to identify the homogeneous sections based on deflection or subgrade strength or surface curvature index. Any of these parameters can be used using cumulative difference approach. Okay. I'm not covering more about it. One can refer section 6.2 of IRC 115 for this. Okay. Then back calculation of layer moduli. Measure deflections has to be normalized, as I discussed. That data has to be used in the KGP back software, and radial distances at which deflections are measured. Means that is the spacing of geophones has to be mentioned. Then actual layer thickness. This is measured from the field by measuring at every half kilometer. Then Poisson's ratio value of different layers. Approximate values are or tentative values are given, or we can say standard values which are given in the standard can be used for back calculation of moduli. Okay. And applied peak load and loading plate radius are used to back calculate the elastic modulus of different layer of the existing pavement using appropriate back calculation technique. See, I'm mentioning KGP back. It is not hard and fast. You have to use that. There are many other softwares available for same purpose. One can use that as well. Okay. And now let's see for back calculation, another important aspect is initially we have to assume some range or some set of values. It's also called as a seed values. Remember I said while calculating this, we have to match the measured deflection bowl with the calculated. For doing so, initially we have to assume these values. Okay. For that, suitable modular regions have to be assigned. For subgrade, it can be 20 to 100 megapascal or 5 to 20 times of CPR, which can be measured from DCP, in situ CPR. Okay. Alternatively, it can be measured using the equations based on this 1200, 1500, 1800 spacing deflection corresponding to these geophones. That can be used to calculate the tentative moduli for subgrade. This will be considered more accurate compared to this. Okay. And granular layer 100 to 500 megapascal. And for bituminous layer, for thick layers without much cracking, if the condition is good, then one can consider from 750 to 3000 megapascal. If the bituminous layer is badly cracked, if the condition is fair to poor, and then one can consider 400 to 1500 megapascal. You can say almost half of it. Okay. Then how it is calculated means basically you can see in this plot there is a measured deflections at different sensors. So with these different sensors we will get a deflection bowl, and we have to match the calculated deflections by using different combination of modulus. And this has to be brought together by minimizing the error, root mean square of error. This has to be minimized. When these matches or when these both deflections come closer, those moduli set can be considered as a final one. Okay. Usually it takes really good amount of time for more number of iterations. That is the reason these programs or algorithms will help us to identify the modulus. Okay. This is a screenshot of KGP back software. It is simple software, but we have to judiciously select the moduli values for getting accurate back calculated modulus. Then comes correction. See, after calculating the modulus, back calculated modulus from the software, we have to apply correction. And correction is, temperature correction is applied only for bituminous layer because the stiffness of the bituminous layer depends on the temperature. Okay. And standard temperature considered is 35 degree. If the pavement temperature is 35, no need of correction. Or if you apply, the factor will come 1. It is as good as no need of applying correction. If any measurement is deviating from 35, one has to apply the correction, because the temperature is lower means it reflects the stiffness of the layer is high, and vice versa. If the temperature is more, it may become soft and deflection might be more. So we have to apply the correction. Okay. For that, these equations are given in IRC, and this is the correction factor, and this equation is applicable in the range 20 to 45 degree. That is the reason if we measure beyond that, we cannot apply this correction. So better not. That is the reason code suggests we should not conduct the FWD after 45 degree, or if the pavement temperature is exceeding 45 degree. Okay. And also there are some more criteria. Temperature correction need not be applied to back calculated modulus of a thin bituminous layer. If existing bituminous layer is 40 millimeter or less, then no need to apply for the correction, temperature correction. Also, if the pavement is poor condition with a badly cracked or distressed condition, then also temperature correction is not applicable. Okay. And also temperature correction is not needed for colder areas. Remember these points whenever you are analyzing the FWD data. Then comes seasonal correction. Usually what happens, pavement will undergo more deflection when it is in saturated condition. This condition happens immediately after the monsoon, post-monsoon, during monsoon, isn't it? So whenever we conduct this FWD survey, if we conduct in monsoon, no need of applying correction. Other than monsoon, if we conduct in the winter or summer, we have to apply the correction as per this equation. For example, this first equation is applicable for subgrade correction when measured in winter. Similarly, this second equation when we measure deflection studies in summer. Okay, this equation has to be applied. Similarly, for granular layer, same way, only equations are different. Then comes, after applying correction, now we are getting so many deflection modulus values. Now, which modulus has to be considered for the calculation of remaining life? For a given homogeneous section, number of modulus value for each layer are back calculated, and for each layer and for a given homogeneous section, select 15th percentile elastic modulus. Means 15th percentile means only 15% or 15% value will be less than this value. Remaining 85% cases, it will be higher than that value, so it will be in a safer side. Okay, this will be considered as a representative moduli for that layer in that homogeneous section. Okay, this same thing has to be repeated for all the layers: HMA layer, hot mix asphalt layer, granular layer, and subgrade layer. Okay, just I'm showing a representational picture here. This is a plot of a percentile. Okay, like we consider 85th percentile speed in geometric designs, right? Likewise, we have to consider 15th percentile modulus value for the calculation of remaining life. Okay, that will be considered as a representative value. Here you can see we can plot the percentiles, and then we can see exactly how much value we take. In this case, if we take roughly in between these, maybe around 40 or so, 40 Pascal megamet is approximately. If you see 40, hardly one value is beyond this. All values are above 40 only. Likewise, only 15% of the cases value can be lesser. Okay, so it is possible even you can take only corresponding to 1 percentile or 0 percentile, but it may become uneconomical. Okay, then comes remaining life. Okay, see, remaining life is we have to calculate using IIT Pave. I hope by now all of you are aware of IIT Pave software, which is used for flexible pavement design as per IRC method. Okay, these 15th percentile moduli values which we determined has to be used in the IIT Pave to calculate or to determine the actual critical strains or actual strains at critical locations. Okay, these strains will help us to determine the remaining life using these models. rutting and fatigue models which are given in IRC 37 2018. Basically, we have to enter the strains and we have to calculate the fatigue and rutting life remaining against fatigue failure and rutting failure. Okay. And remember, we will be getting two different values. Maybe we may get 5 million standard axles from the fatigue point of view, and maybe 8 or 10 million standard axles from rutting point of view. Remember, out of these two, we have to select the shortest one. If 5 is the minimum number, we have to take 5 and we have to consider 5 million standard axle is the remaining life. Okay. If the remaining life is greater than or equal to leftover design life, then no need of overlay if there is no change in the traffic. If any change in traffic is there or remaining life is less than leftover design life, then one may have to go for a overlay. Okay, let's see how that can also be done. So this is for each homogeneous section. We got a 15th percentile modulus, as I mentioned in the earlier slides. Okay, and also corresponding layer thickness, bituminous thickness and granular layer thickness. These are actual thicknesses from the field. Okay, then these are the critical strains, tensile strain and rutting strain, which we got from the IIT PAVE software. Based on the models given in IRC 37, one can calculate the remaining life from rutting as well as fatigue point of view. Okay, and after this, we have to see our remaining life, what is the traffic is remaining, how much traffic it has to cater. If it is satisfying, well and good. If not, in this case, let's say design traffic for the overlay is 50 million standard axle, which it is not going to sustain, isn't it? Many sections. So we have to calculate the additional overlay thickness needed for it. Before that, we have to calculate allowable strains for this traffic. How much strains can be allowed using the rutting and fatigue models given in IRC 37. After this, we have to perform the strain analysis in IIT PAVE considering new layer, one additional layer in the bituminous overlay. Okay, pavement is modeled as a 4-layer system. For conventional pavement design, we model it as a 3-layer system. Okay, in this 4-layer, top layer will be new bituminous layer with the new properties. Either you can take actual resilient modulus or from the indicative values given in IRC 37. But pay attention, second layer is another bituminous layer, that is existing bituminous layer, and this modulus is from the FWD data, back calculated modulus. Okay, and thickness whatever available in the field. And similarly, this granular layer is a back calculated modulus and existing thickness and modulus of the subgrade. Okay, from this we have to analyze and we have to check the critical strains. If they are within the allowable range, we can say assumed thickness is satisfying, we can go ahead with that overlay. If not, we have to change this value and we may change VG30, VG40, whichever is needed. Accordingly, once again, we have to perform this analysis. Okay, in this case, with this combination, we are getting strains are actual strains are within the allowable strains. So we can say 90 millimeter thick overlay can be provided for it. Okay, and now let's see the design, stepwise design methodology, so that quickly I will go through it so that we will have some time for the discussion. Okay, first we have to measure the surface deflection of an in-service pavement using FWD, means already existing pavement. We have to conduct the FWD survey. And after that, we have to normalize the data, deflection data to 40 kilonewton standard loading, peak loading. Okay, and then we have to collect the information related to layer type and thickness by performing the test bit or any alternate method at every half kilometer intervals. Okay, and then we have to back calculate the each layer moduli using KGP back software. Remember here, giving seed values, selecting sensibly the lower and upper limit of the moduli is very, very important. Okay, then after back calculation, we have to apply the temperature correction for bituminous layer and seasonal correction for granular layer and subgrade layer. Okay, that is corresponding to post monsoon condition. Then we have to analyze the in-service pavement using layered elastic theory in IIT PAVE. Okay, with the back calculated moduli and existing layer thickness, which are collected from the field. And we have to check the critical strains, that is horizontal tensile strain at bottom of bituminous layer and vertical compressive strain on top of the subgrade. Okay, After using these strains, one can estimate the remaining life using the fatigue and rutting performance models given in IRC 37 2018. Okay. And then usually it is recommended for the design of overlays 10 years. Okay. And however, less important roads are there, then one may go for up to 5 years. Okay. This is in general. But here one has to pay attention is where to check the strains. See, for overlay, what we are doing after checking the remaining life, we are assuming a trial thickness, isn't it? And then we are checking the critical strains, whether it is within the allowable limits or not. Okay. But when we are checking here, we have to note that critical strains at the bottom of old bituminous layer and top of subgrade. I think top of subgrade is clear for all. Okay. But in bottom of bituminous layer, there are two bituminous layer. There are high chances that many will get confused whether to take below the new bituminous layer or below the old bituminous layer. Here, that is the reason you have to pay attention and always check the critical strains at bottom of old bituminous layer. Okay. And compressive strains can be checked on the top of the subgrade. And these strains are whenever they are within the limits of allowable limits, then this can be considered as a safe. Okay. A typical design example is presented in Appendix 4 of IRC 115. Okay. I will show. And KGP back software demo. There is a software called KGP back, which will be accompanied with this guidelines. Whenever you purchase IRC 115 2014, you will get a CD with this software that can be used. Simple software. Okay. And I would like to show a data sheet. This is how this kind of data has to be collected when FWD survey is conducted. For each section, basic information like road type, carriageway, and homogeneous sections, and from to which direction. Then you can see these are the distance of the geophone location. Remember, 0 means under the load, then 300, 600, 900, 12, 1500, up to 1800 millimeter one can go. Okay. At each point, we have to have this deflection data. Then also temperature at every half an hour. Okay. These has to be collected for further data analysis. Okay. Once we have that data, easily we can perform that. Okay. Before going to demo, that just I would like to summarize, then I will go for software demonstration. In this presentation, we have seen both functional, just basics of functional evaluation and structural evaluation, and overlay methods by PBD, that is an old deflection method, and its drawbacks, why we have shifted for new technique, that is a mechanistic empirical method, that is a FWD technique. Okay. Then back calculation of layer moduli for each layers, and correction of moduli both for temperature and seasonal. Remember, temperature correction is applicable only for bituminous layer, whereas seasonal correction is applied for granular layer and subgrade layer. Okay. Then overlay design methodology as per IRC 115 we have discussed, and KGP back software demo I will show it now. Okay. Before that, I would like to show the photographs of an actual FWD. Okay. This is one of the FWD from Maharashtra, Nasik, one of the consultant they had. You can see this is not trailer type. This is a VMFD, vehicle mounted falling weight deflectometer. Okay. This complete setup is having FWD. This is how it looks. You can see this is the loading plate, which is accompanied by rubber pad, and there is a geophone exactly at middle of the plate as well. Okay. And there are different geophones at different spacings. You can see series of geophones are there. Okay. And this is from another view. Okay. And this is how it will be position of the FWD while measuring. First, initially, this complete arrangement will be lowered and it will be in touch with the pavement. At this time, first load will be dropped. That is considered as a seating load. And remember that data has to be discarded. And next 3 drops will be performed and deflection data has to be considered. If you see here, this is the loading plate. Here one geophone is there. Likewise in this, here at series, geophones will be there. They will be recording the deflection data. Okay. And this was the team at IIT Bombay when we had demonstration of this FWD. That's all. And I would like to acknowledge Professor Dharamveer Singh, where he got us this. We got opportunity to see and demonstrate the FWD data and work with FWD data. And also I would like to thank Ramaiah Institute of Technology for inviting me for this FDP and sharing my knowledge with all the presenters. Okay, organizers and participants, if they would like to know more or if you want to read more, you may refer IRC 115. These are parallel. Whenever you are performing overlay design, you have to refer this, and IRC 37 also. And ASTM D4694 is for FWD. If somebody would like to refer, they may refer this as well. And if you have any questions, you can ask meanwhile. And if organizer says if time is there, I will demonstrate software with you. Yes, sir. Professor Vivek, are you there?
Yeah, definitely. We have some questions in the chat box. Maybe
okay,
I will
let me check. Let me answer. Yeah, you can.
What is the accuracy level of BBD and FWD? This is a question by Raghavendra N.
See, this is quite difficult to answer straightforward, like what is the accuracy level, but it has been stated that error involved in BBD will be more. If you see the way we measure, it is a manual method. Many times we have to check the sensitivity of the dial gauge, whether it is properly working or not. Okay, so definitely the accuracy involved in BBD will be relatively lesser compared to the FWD. And FWD, we use geophones, which are sophisticated compared to dial gauges for measuring the deflection data. So I cannot say with a number this much, but definitely FWD data is more reliable compared to BBD data and accurate as well.
Yes. We have one more question from Mr. Ashok Kumar. The question is like, is it possible to estimate remaining life identification of sections for reconstruction or pre-overlay, repair and overlay design with FWD data?
See, let me read once again. Is it possible to estimate remaining life identification of sections for reconstruction, pre-overlay, repair and overlay? Definitely this particular data, whatever I presented, we can estimate the remaining life. Only the requirement is deflection ball we need. In addition, we need an individual layer thickness, existing pavement layer thickness. If we know that, and with the assumption of sensible modulus values, upper and lower limit, we can easily calculate the back calculated modulus. Once we have these values, easily we can calculate remaining life. That is possible.
Yes, we had a same person asking for one more question.
Yes.
Does the moving vehicles adjacent to FWD equipment while carrying the survey affect the deflection readings?
If you ask me, definitely it will affect. But the thing, if you see, within a fraction of a second, it will collect the data. So usually it is recommended to wait if any moving vehicles are there. Whenever they pass, this data has to be taken.
Okay. It
will not take much time, unlike BBD. In case of BBD, we have to wait. We have to take first reading, again vehicle will be moved further. We have to take second reading, one more reading has to be taken. Their time required will be more. There are high chances either we have to wait a lot of time or during that time the vehicles may fly side by that. But in case of FWD, it is a very quick method. It doesn't require much time. Dropping and collecting data is a fraction of seconds time, I can say. Within that timeline, it is done.
We have one more question from Mr. Gaurav Singh Rajawat. Yes, why do we consider different Poisson ratio value than new pavements even for overlay layers?
Okay, why do we consider different Poisson ratio value than new pavements even for overlay layers? No, overlay layer is considered as a new overlay. There it is not a different. It is a actual Poisson ratio we are taking like a new design. No need to consider a reduced down or something.
Okay.
When we consider overlay, that is a new layer. And whatever the properties we take in a new flexible pavement, that properties can be taken directly. Absolutely, that is correct.
Okay. Any more questions from the participants? Yeah, sir, participants are awaiting one of your demos.
Yes, sure. Definitely, I will be happy to demonstrate. That is not a very big software. Everyone can perform it. If any questions are there, I will be happy to take. And meanwhile, I will share entire screen. Then only I think all of you are able to see it.
Okay. So let me.
Yes, sir. Meanwhile, I will be answering the questions. Just I will reshare entire screen once again.
No, there are no new questions. It's there the discussion.
I think, can organizers guide me? It is taking one window, how I can share an entire screen. I would like to share my complete desktop. Is it
You
possible?
have to open the software
Okay.
and share that screen of the software. Sir.
Only that
That
screen?
screen option is not the case.
That I can able to, but I wanted to show side by side input values from the code. Okay, if that is not possible, that is fine. I hope all of you can see my this black screen, right? This is a software, yes. Small software,
Yes,
KGP
yes.
Bank software. Okay, sir, if there are no questions, I will go ahead with this. And if any of you are referring to IRC 115, I would like to take that example, which is given in the appendix at the end. So that
Hello, sir, some questions are there in your chat box.
Okay, sir, let me see that.
Excuse me.
Okay, most of the time road is upgraded as per the increased traffic instead of FWD analysis. Remember, even for increased traffic, we have to do an FWD analysis to know the existing condition. As I said, remaining life might be 5 years. That 5 years, if you calculate traffic as of initial design period, it might be different. But if you analyze the traffic for the next 5 years based on the current scenario, it might be different. But definitely based on the, as I mentioned, usually typically overlay designed for 10 years. We have to see the traffic for next 10 years considering the present scenario. For that traffic, we have to design. For designing, definitely we need to know the existing condition that is possible through FWD. Sir, is there any answer? I think one of the participants is answering recommended values of Poisson's ratio 0.5, 0.4, and 0.4. It's correct. What is the impact? I'm not getting this question.
Maybe what is impact load over?
It is an impulse load. It is an impact load and it is a dropping weight. But if you see the contact of the load, it is in milliseconds. It is closely similar to the moving wheel loads. That way it is more appropriate compared to the static or creep roads. Under that load, measuring deflection is very challenging, but with the help of this instrumentation and geophones, it is possible to measure that load deflection under that load pulses, exactly corresponding to the peak loads.
No.
Basically, they will be measuring continuously, but data will be refined to get the deflection corresponding to the peak loads. That will be used for analysis purpose.
Yes. Thank you. Now you can go with demonstration.
Demonstration. Okay.
Yes.
If you see this, when we open this software, it says welcome back, welcome to KGP back program. This is developed by IIT Kharagpur. Okay. And this particular software is based on genetic algorithm. Okay. And let me demonstrate here. There is an important note for good back calculation result. The modular ranges have to be selected judiciously. Okay. That in later stage it will come. First it says type peak load in Newton and contact pressure. Also standard values are given. You can take directly 40,000 Newton or 40 kilonewton. Remember we used. And here we have to enter values with the spacing. Okay, 40,000 first is a standard load, followed by a space, which I am using 0.56 as a contact pressure. Then how many deflections were measured? Okay, I am going with the appendix 4 of IRC 115. Here I can see 7 geophones are used. After that number, it will ask what are the spacing. Definitely first geophone will be under the wheel load, under the exactly drop weight. Next is at a spacing of 300. Remember here we have to do give this number with space 0, space 300, space 600, and so on. Okay, 900, 1200, 1500, and 1800. Okay, then print measure deflection in millimeters. Now we have to enter deflection values corresponding to each geophone. Remember the order should be same. Okay, I'm entering 0.481. That is a deflection corresponding to 0 distance, means exactly under the drop weight. Okay, next deflection. Next, you can see these values, they are decreasing, right? Because as the distance from the drop weight is increasing, deflection will decrease. That makes sense, right? This we have to check it initially while screening the data. If anything is not logical, that set has to be eliminated or should not be considered for further calculation. After entering this data, it is asking for give the pavement related inputs, 3-layer system ranging from the top. Okay, basically first we have to enter the thickness of top layer. Okay, let me take thickness of the top layer. As per this code, it is 170. Remember, this is the thickness of top layer, means bituminous layer. There might be BC, DBM, 2-3 layers. We have to enter combined thickness of bituminous layer. Okay. Then thickness of granular layer. That is, it can be WMM plus GSP. Okay. And also, please note that no need to enter thickness of subgrade. Okay, it will be considered semi-infinite. Even in the new pavement design also, we will not enter the thickness. Okay. I have entered. Now it is asking for type Poisson's ratio of each layer starting from the top. Okay. Also suggested values are given. I'm taking same values, but here we have to enter for all 3 layers. That is bituminous layer, granular layer, and subgrade as well. Okay. Do not miss for subgrade. Only thickness is not needed. Once after entering, it is asking for input range, lower and upper for each layer modulus. These are the seed values we have to consider. Okay. And again, it has to start from the top. I'm taking top layer, bituminous layer as a good condition, 750 to 3000. Okay. And enter. This is for first layer. Then comes a granular layer. It is combined 100 to 500. Okay. Then for the subgrade, there are various conditions. Okay. Either we can use the equation or we can take the CBR based 5% to 20% of the CBR. Okay. I'm taking in this case 50 to 80. Okay. Then enter. Now you can see you can find the results in backout file in the same directory. Use Notepad to see the result. KGP back is running, please wait. So you have to wait, automatically this window will disappear. Okay, that is running in background. This is done, only this much is the input we have to give. And we will get the output result in a Notepad form. And this process it takes varies from system to system. Okay, because this window has closed, let me share once again. I will open the output file. See, when I open output file, it looks like this. You can see here in this, initially input values, it will show whatever data we have given input. Okay, check that. And at the end, we can see output, back calculated layer modeling. For surface layer, base course, and subgrade, it is given. You can see these are the values. This is called a back calculated modulus. And further, this modulus has to be corrected for temperature, for surface course, and for seasonal correction for base layer and subgrade layer. Okay. After that, we have to take the percentile, that is 15th percentile value in the IIT PAVE. I hope this is clear. If you have any doubt, let me know in this. Yes. Any doubt in this, participants?
Participants have the forum open for any kind of discussion or doubts.
Yeah, I would be happy to answer, or any questions, discussions, all are welcome for.
Okay. If there are no doubts, then we would like to end the session by thanking Mr. Ayyanna Habal for your presentation, for you being with us for this FDP. We are grateful to you and we hope to see you soon again.
Thank you so much, sir.
Thank you so much for being here.
I would like to thank you and all the participants for patiently listening this lecture. Thank you so much. Even if you have any doubts, you can always drop an email on this email ID. Feel free to contact.
Thank you so much.
Thank you.
Thank you, sir.
I now request Dr. Vivek Das to take over the platform and bring out a brief summary report of the 5-day faculty development program and give a bird view of the presentations which have happened.
So, thank you, Mr. Niranjan. Good afternoon and welcome you all for the final summary report celebration on the 5-day faculty development program on the theme Advances in Highway Technology and Traffic Engineering, organized by Department of Civil Engineering, Ramaiah Institute of Technology, Bangalore. It was a wonderful experience with you all for the last 5 days. We hope that the FDP provided exposure to the participants and provided a chance to enhance their knowledge in the subject area. To give a brief summary of FDP, we got about 196 registrations from different parts of the countries. We have representation from all parts, north, east, west, and south of our country. The FDP was conducted on online mode. The platform used was Zoom. The program started with inauguration by our HOD. He shared his views of conducting such FDP and its importance. He also briefed the participants about the subject chosen for the FDP and highlighted the reason and importance for the same. This was followed by various technical sessions. The day one technical session started on 7th February 2022 at 10 a.m. with keynote session by Dr. Satish Chandra, Director CRRI and Professor IIT Roorkee, and ended today 11th February 2022 just now by Dr. Ayyanna Habal on the topic of structural evaluation of pavement, which is the most advanced method used in pavement overlay design. We have experts from academia, industry, and interdisciplinary areas also. Total 15 resource persons delivered a talk. In that 11 we have external resource persons and 4 internal resource persons. We hope that overall the 5-day FDP program was successful in teaching upon some key issues of the theme and was very knowledgeable and helpful. Thank you.
Thank you, Vivek sir. That was a brief introduction, brief report of the summary. I would now request the head of the department, Civil Engineering, Dr. I. Venugopal, to address the gathering.
Good afternoon to all of you. Actually, it is indeed a privilege and a pleasure for me to be part of this valedictory function. Though I wanted to listen to every one of the talk by the experts, but because of the multiple duties or the responsibilities I'm entrusted with in the institute, I was not able to do. But certainly, I have the copy of their video versions. Late in nights, I have been listening to them. I've been so much impressed with the content and the quality of the talks and the speeches made by the illustrious speakers. And as you know, as our professor, Mr. Das, has concluded, the session of the FDP has started from 7th February to 11th, and this 5 days, how it has gone is very difficult to imagine. That means I was just keeping a track, almost I will see 70 to 80 to 90 participants on the video mode, I mean offline, online mode, and it's very nice to see such a good presence. And the interactions with the questions and answers are also very absorbing, and definitely gives an impression to us that it was a very beautiful program kind by the Department of Civil Engineering at MSRIT, Bangalore. Just to enumerate the things, as Mr. Das told it, there have been 11 external speakers. When I go through the profile, there are illustrious speakers with a tremendous track record of academic excellence, plus close association with industry works and extensive research in various materials or various aspects of the highway engineering. Just to recollect the names, Dr. Satish Chandra sir from IIT Roorkee, and Dr. Ankit Gupta, Dr. Rajat Rastogi, Dr. Ashish Verma, Dr. Partha Pratim De, and Mr. Arun S, and Professor M.N. Srihari sir, and Dr. Asha, and Mr. Shivkumar, Mr. Abjit, and Dr. Ayyanna Habal. All these people have shared their wonderful contents of the highway engineering with all the participants. I'm very much sure that all participants have definitely got benefited, and it has opened their inquisitive inside to learn more and more on this all aspects. That's a wonderful service given by all these great speakers. Really, I thanks all of them. Wholeheartedly, I thank. Of course, internal speakers were also there. My colleagues, Dr. MC Natra sir, and of course, Mr. Vivek Das, being a coordinator, also has delivered a good lecture. And Dr. Nisar Ahmed, another professor here, and Mr. Niranjan. Apart from this, I also should take an opportunity to thank all of my active colleagues here who have really made this program a grand success. That's Mr. Das and Mr. Nandesh and Dr. Niranjan and Mr. Charan Prasad and Mr. Pramod and other supporting staff. They really worked day and night. I know that how difficult it is to organize a program, but they did it in a successful note. So my heartfelt thanks and gratitude to all of them. Coming to the topic, having it opened a debate on various aspects of the field, I just want to conclude with a remark. Highway engineering is a kind of a specialized field where you can see the application of all the concepts of civil engineering merged together. May it be new materials, every day there is a need for the new materials which need to be used in a large quantities because the work demands our pathways, our roads run into thousands of kilometers. So a lot of invention on the new materials, especially local building materials, local available materials will go a big way in making the construction most economical and also sustainable. And also design concepts need to be changed over a period of time. And site investigations are thoroughly required to assess the subbase and base characteristics. And of course, the fatigue is always there because the roads are subject to a tremendous repeated loads. That too, in the present context, with a lot of repeated loads of the high vehicles, that too very high going with the fast going vehicles also. And wheel technology also developed a lot. So a lot more stress and strain and fatigue is experienced on our roads. And of course, these moving loads, if not dynamic loads, of course, coming to the dynamic loads, always earthquakes can cause a major damage to the roads, as we can see in the newspapers and some kind of articles. All in all, what I would like to say is, all aspects of the civil engineering professions are involved in our highway engineering. So that's really a tough challenge. One has to have a thorough knowledge, if not totally mastery over there, but at least you should know what is the real related topic, who is the right person to be contacted, how to get the most reliable information there, and assimilate all information, put it in one globe, and look at it in detail and adopt the innovative means and designs to see that our roads will be permanent and long-standing. Because at the end of the day, we are all the responsible citizens of the Indian society, where we are definitely answerable to the common man. And actually, this is only the field where a common man, irrespective of the cadre or stature, uses every part of your product. Every person uses the roads, irrespective of any criteria. So we have more answerability, more accountability. So therefore, all the technocrats need to come together and use their expertise and come out with the most viable and a comprehensive solution. That is the urgent need, the present day. So in this context, I would like to make two statements. Such kind of FDP programs will certainly help us to rope in and come together as a good team and also to share our knowledge on such a wonderful platform. The second aspect is, we being in academics, especially myself and my colleagues, certainly we are the people who need to take an initiative to come forward and bring forth to the industry. Essentially in India, the roads, building and management is still under the government purview only, unlike in the foreign countries. Therefore, we would like to approach the government bodies and tell that here is an expertise available where we can solve the burning issues of the road transport and highway engineering. So we would like to take initiative in the direction and approach the government bodies. Certainly, the government officials were also a part of this wonderful FDP program with their good officers. They will ensure that we will be heard. They will listen to us, and a kind of a chosen topic or a chosen problem can be given to us. So at that point of time, with the expert available with us and with the coordination we have been entertaining with all of you on different platforms and forums, we'll form a kind of a integrated team to solve the given problems. Certainly we'll come back to you and revisit you also Depending upon the situation, we will request all of your people's expertise and knowledge and good offices and come together as a good team, a comprehensive team, and solve such kind of a problems. And we hope that government will certainly give an opportunity for us to identify the problems and solve them with the support of all of you. So with these few words, I will take a leave of you on a big note, telling that this program has been extremely well conducted and wonderfully attended and well presented, and every participant has shown a lot of interest and every faculty member has done their best. So I sincerely thank one and all and wish you all the best and look forward to meet you very often. Thank you, sir.
Thank you.
Thank you so much, Venugopal sir, for those inspiring words and heartfelt message. I would like to conclude this 5-day faculty development program, Advances in Highway Technology and Traffic Systems, with a word of thanks. No duty is more urgent than that of returning thanks. Gratitude is not in words, but in the heart which expresses it. I deem it a great honor and privilege to propose the vote of thanks on this memorable occasion. Let me first of all start by giving glory to the Almighty for making the faculty development program a resounding success. First and foremost, I thank our management and the principal, Ramaiah Institute of Technology, who went on to give a go-ahead for this program. I express my heartfelt thanks to our beloved head of the department, Dr. I. Venugopal, for the encouragement and support provided to roll out this faculty development program. We are equally grateful to Dr. M.C. Nataraja, former head of the department, Civil, in whose tenure the seeds of this FDP were sown. He made it sure that the FDP found its place in the busy schedule of the academics. I owe special gratitude to the coordinators of this FDP, Dr. Vivek Das and Mr. Charan Prasad, without whose support, one would not have imagined the FDP to happen. From taking the permissions from the authorities and helping their hands in deciding the speakers, they have contributed to make sure we got the best of best speakers for you all. For me, every hour is grace, and I feel gratitude in my heart each time I meet someone and look at their smiles. I owe my special gratitude to Mr. Nandish, the technical head from our very own RIT, for having been with us despite his busily scheduled classes and he being with us in spite of all odds for 100% online technical support, right from helping in creating the links to the smooth conduction of the FDP on this Zoom platform. Thank you, Nandish. I also have special gratitude and like to thank Shri Pramod, the instructor and maintenance engineer of our very own department, for his critical and timely help and support. Programs could not be better if we would miss out those yummy refreshments for the days. And in this regard, I would thank Ms. Nagaratna and Mr. Sharath for their constant services of refreshments served to us. I thank all the distinguished invitees, participants, and the speakers for having humbly accepted our invitation and being a part of our faculty development program. But for your presence, this FDP would have been out of imagination. Distinguished speakers, we have learned a lot from you during this faculty development program, and standing true to the name, we are looking forward in the direction of development after having listening to your talks. In the end, I thank all our colleagues in the Department of Civil Engineering, both the teaching and non-teaching ones, for having been with us, for having supported this program to make it a success. Finally, I leave you this inspiring quote by Martin Luther King. An individual has not started living until he rises above the confines of his individualistic concerns to the broader concerns of humanity. I once again thank you all for your attention. Thank you, one and all. Thank you so much.
Any of the participants would like to speak?
I would now request or I would like to ask if any of the faculties would like to give their feedbacks regarding this faculty development program. You can be as straight as possible, no problem with that. Anyone who likes to share their ideas or message or feedbacks? Okay, you can get to us with our website. The certificates and the PPTs of the presentation would be sent to you within a span of 1 week, as we need to process the certificates, and any other feedback is always welcome. So again, would like to thank you. Thank you, Ananda.
Okay. Okay. Thank you.